Okay, in this video we will be discussing dimensional analysis. Now, dimension of a physical quantity. We know that the derived units of all physical quantities can be obtained from the fundamental quantities of mass, length and time. Of mass, length and time. Let the fundamental unit of mass be represented as m. Now, this is how the fundamental unit of mass is represented. The fundamental unit of any sort of distance or length is represented as capital L, and the fundamental unit of time is represented by this capital T. Now, if suppose we have to obtain like the derived unit of volume, we know that volume is L into B L into B into H. L into B into H. Now, so the volume will be, we know that length will be same as L into breadth is again length, and this is again height is also expressed in length. So basically this is L to the power 3. L into L into L, L to the power 3. Now, to represent the volume, what we have done is that we have raised L to the power 3. Therefore, volume is said to have 3 dimensions in length. Or we can write volume as like M0, L3 and T0. And say that volume has 0 dimension in mass, has 3 dimension in time, in addition to 3 dimension. Had 0 dimension in mass, 0 dimension in time, and 3 dimension in length. Now, velocity. Velocity is expressed as velocity. We know that velocity that is equals to displacement by time. Displacement upon time interval. So this is equals to L upon T. Now we write velocity as Lt minus 1. And also we can write this as M0 Lt minus 1. M0 Lt minus 1. And the dimension of velocities are 0 in mass, 1 in length and minus 1 in time. So from all this dimension analysis, now we can define dimensions. So dimensions of physical quantity as the power to which the fundamental unit of mass, length and time, fundamental unit of mass, length and time have to be raised to derive the unit of the quantity. So basically, what is the dimensions? Dimensions are the powers to which these fundamental units like mass, length and time are raised. Now the dimension formula of physical quantities can be obtained by defining their relation with other quantities whose dimension in mass, length and time are already known. So we will be discussing these like in future videos. So now the use of dimensional equation. Use of dimensional now these are the dimensional equations. So first use is basically conversion of one system of units into another. So this is conversion of one system of unit into another system of unit. Conversion of one system of unit into the another system of units. Now, let's discuss this. Let's discuss the first point. Now, this is based on the fact that magnitude of a physical quantity remains the same, whatever is a system of measurement. Now, if suppose this Q represents the magnitude of a physical quantity, so this is basically N1 U1, which is equals to N2 U2. This we know. U1 and U2 are the units, are the two units or two different units of measurement, and N1 and N2 are their respective values. For example, if you are measuring the length of the table and you have chosen the unit meter, so suppose its length is 2 meter, 2 meter, and when you have chosen centimeter, that will be 200 centimeter. So this is N1 U1, N2 U2. So this is how this is defined. So N1 U1 is equals to N2 U2. Okay, now if suppose let M1 L1 and T1 be the fundamental units of mass, length and time in one system. So in one system, let it be M1 L1 T1. Okay, and M2 L2 T2 be the fundamental units of mass, length and time in other system, and let ABC be their respective dimensions, like raised to the power A, raised to the power B, raised to the power C. Similarly, raised to the power A, raised to the power B, raised to the power C. So ABC be the respective dimension of quantities in mass, length and time on both the system. The unit of measurement U1 and U2 of the two dimensions would be. So now U1 will be M1A, L1B, T1C. U2 will be M2A, L2B, T2C. Now, from equation 1. Now, if we use like this equation, okay, N1 U1 is equals to N2 U2. So basically, see, N1 U1 is equals to N2 U2. Now, what will be N2? By the cross multiplication, N2 will be N1 U1 upon U2. N1 U1 upon U2 from this equation. Now, what is U1? Is this? U2 is this. M2 L2 T2. Now, substituting the values in the given equation. So, N2 will be, this is N1. You can write this as M1A, L1B, T1C upon, this will be M2A, L2B, T2C. Okay, now rearranging it, what will be N2? This will be N1 times of M1 by M2A, L1 by L2B, T1 by T2C. So, here is the equation. Now, knowing the values of M1, L1, T1 and M2, L2, T2, values A, B, C and N1, we can calculate the numerical value of the quantity into the other system. It should be clearly understood, like in this equation. It is applied only after expressing the quantity into the absolute unit. Or basically, what I want to say is that these two should be in same units. These two should be in same units. These two should be in same unit, so that you can then cancel out the numbers and solve them. Okay. Now, let's take an example. Now, the example is, what you have to do is that you have to convert 1 Newton into dyne. We know that Newton is the unit of force in SI system and dyne is the unit of force in CGS system. Now 1 unit is an absolute unit of force, as I have already told, in MKS system, meter kilogram second, and dyne is of the CGS, centimeter gram second. Yeah, now first of all we should know the dimensional formula of force. Now dimensional formula of force is what? Force is what? Mass into acceleration, that we know. Mass ka we can write m. Now what is acceleration? Is change in velocity. So basically that will be velocity only, Lt minus 1 upon time interval. So this is m, this is Lt minus 2, or the dimensional formula of force is m 1 L1 T minus 2. Now this is the dimensional formula of force. So the dimension of force in mass, length and time are, so what are the dimensions? What is the value of A, B, C? A is what? A is 1, B is again 1, C is minus 2. As we have convert, no, we know that what we have to do is that we have to convert 1 Newton into dynes. So N1 is basically 1 Newton, N2 will be in dynes, but that value we have to find. Okay, now using this equation, okay, so let's write this equation. N2 equals N1, that is M1 by M2 A, L1 by L2 B, sorry, T1 by T2 C. Okay, we have written the equation. Now time to solve. N2 is what? N1 is basically 1. We know that N1 is 1 Newton. Now M1 is in kg. So this is, we write 1 kg and this is 1 gram. What is A? A is 1. L1 is meter. 1 meter. L2 is 1 centimeter. What's the value of B? 1. Both are in second. No problem. They will cancel out each other. C is minus 2. So now, again, this is 1 kg is 1000 grams. 1 gram to the power 1. 1 meter is 100 centimeter. 1 centimeter to the power 1. This will be 1 only. So 1000 gram will get cancelled. Centimeter will get cancelled. So N2 is 1 into 1000 into 100, which is 1, 2, 3, 4, 5, or N2 is 10 to the power 5 dynes, dynes. So we got to the conclusion like 1 Newton is 10 to the power 5 dynes. Sorry. So 1 Newton is 10 to the power 5 dynes. Okay, our next question. Now find the value of force of 100 Newton on a system based upon the meter, kilogram and minute as the fundamental units. Now see, we know that Newton is an absolute unit of force on the MKS system. Okay, we know that force and we have to convert it into the new system. Now the new system is the meter, kilogram and minute. So this is the new system, and Newton, as we already know, is in the MKS system. So I have to convert that MKS system into the new system. Dimensional formula of force we have already discussed. F is M1 L1 T minus 2. This is the dimensional formula of force. Okay. So the dimensions is A equals 1, B equals 1, C equals -2. So these are the dimensions of force. Now for MKS system to new system. Now see what is M1. M1 is 1 kg. Now 1 represents that MKS system. L1 is 1 meter. T1 is 1 second. Okay. Now the new system. New system is meter, kilogram, minute. So M2 will be in kg only. Is 1 kg. L2 will be meter only, will be 1 meter. And T2 is 1 minute. So this is 1 minute. Okay. Now we know that N1 value is 100 because that's 100 Newton. Okay. 100 Newton, and we have to find N2. Now again, using this formula, so let's rewrite this formula again using this formula, which is N1 equals N2 M1 by M2A L1 by L2B T1 by T2C. So now value N2, sorry, this was wrong, sorry, N2 equals, this is N1, this is N1. Okay, there's a formula. N2 equals N1 times this. So N2 equals N1. Now N1 is what? 100 Newton, this is 100. Okay. M1, this is 1 kg. M2 is also 1 kg. Now what is A? A is 1. We know. 1 meter. 1 meter. This is what? 1. Now this is 1 second. T2 is 1 minute, which is 60 seconds. And this is to the power -2. You can check the values of ABC. C is to the power -2. Okay. So N2 will be, this and this will cancel. This will get cancelled. Now this is 60. So 60 into 60 is 3600 because it's a square and it's -2. So this will reciprocate. So 100, or just write into, this is actually 1 by 60 to the power -2, or you can write 100 into 60 to the power 2. So this will be N2 equals 100 into 3600. 60 square is 3600. So N2 is 360000. New, we write new unit of force. So this is what the new unit of force. Okay. Now we have, next point is checking the accuracy of formula. Now, whether a given relation of formula, formula like equation is correct or not can be checked on the basis of, this is known as the principle of homogeneity of dimensions. Now according to this principle, only that formula is correct in which the dimension of various terms on one side of the relation are equals to the respective dimensions of these terms on the other side of relation. So basically in that equation, we find, what is LHS and RHS. So we find the dimensions on LHS, we find the dimension of RHS. The dimension of both the quantities should be correct. Now it should be clearly understood that powers of all three, M, L, T, must match the same thing on the power on the other side of the formula. Now even if like one of them fails to match, the formula is actually wrong. Now one more thing that you should know, even if the equation is dimensionally correct, that does not ensure its physical correctness, because we have one limitation which is known as dimensionless constant, which we will be discussing in our questions or the examples that we are taking. Now let's take an example. Now here's the question. Check the correctness of the relation. Now this is a relation v square minus u square is 2as, where the symbols have the usual meaning. You know that v is final velocity, this is initial, this is acceleration, and this is the displacement travel. Okay. So now the given relation is, this is v square minus u square is 2as. Now again same thing, we have to write the dimensions. This is the left hand side, this is the right hand side. Okay, now writing the dimension on either side. So let's start with LHS, left hand side. We know that v and u, though it's final velocity, this is initial velocity, but still velocity's dimension is L t minus 1, this is square, minus L t minus 1, this is a square. So which is L square t to the power minus 2 minus L square t to the power minus 2. This is written as L square t to the power minus 2. Now here is the point to be noted. See, what I have written is L square t to the power minus 2 minus L square t to the power minus 2 is L square t to the power minus 2. Now you must be wondering why I have not crossed these two. See, we are dealing with the dimensions, not the numbers. Dimension means if suppose these are the velocities, they have different values. This might have different value, this might have different value. So when you are subtracting final velocity from the initial velocity, still it will have some value, and which will have its dimension. So that's why I have written L square t minus 2. LHS is L square t minus 2. Now RHS is 2a into s. Now we know that a is acceleration, so its dimension are L t minus 2. We have discussed it. S is the length, which is L. Now the dimensionless constant that I was talking about here is 2. So if it is 2, we cannot write this dimension, and this dimensionless constant is the limitations to this dimensional equation. So RHS is actually L square t minus 2. Now we see that these two equations are equal, like dimensions of LHS is equal to dimension of RHS. So hence the formula is correct. Since the dimensions are equal, the formula is correct. Okay. Our next question. Check the accuracy of the relation. This is nu. This is known as nu, which is the frequency 1 upon 2L under root t by m. This part we have to check. Where nu is the frequency, L is length, T is tension. L is length, T is tension, and M is the mass of unit length of the string. Note that M is what? The mass of unit length of the string. Okay. Now starts. So what's the given relation is? Nu is equals to 1 upon 2L under root T by M. Now, writing the dimensions on either side, we get. Now what is the LHS? LHS is actually equals to nu, which is basically frequency. So frequency is actually t to the power minus 1. T to the power minus 1. And writing its full dimensions, that will be m0, L0, t to the power minus 1. Okay. Now for the RHS. Now see RHS. RHS is 1 upon 2L under root T by M. Again there is one limitation, like 1 by 2 has no dimensions. Okay. Tension, basically this tension T is force, and M This tension T is basically force. Tension is basically the force on the string, so its dimension will be that of force only. Now mass, this is mass per unit length. M is actually mass by length. Mass by length. Okay. Now this is mass by length. So now writing the dimensions of this. So this will be 1 by L under root. Forces, we have discussed force, M L T minus 2, and this is mass by length. Mass by length is actually M L minus 1. So right here M L minus 1. Okay. M will get cancelled. This is minus 1, so this will go reciprocate. This will be L square. This is T minus 2. So this is 1 by L under root of L square T minus 2. So this is equals to 1 by L. This is L T minus 1. L and L will get cancelled. What is left? T minus 1. So writing its full dimension, M0, L0, T minus 1. So you can see LHS was M0, L0, T minus 1. RHS is M0, L0, T minus 1. So dimensionally they are correct. So LHS equals to RHS. So dimensionally these equations are correct. So now, if the equation fails its consistency test, or if it fails the principle of homogeneity of dimensions, like if dimensions are not equal, if it fails the consistency test, it is proved wrong. But if suppose the equation passes this consistency test, it did not necessarily prove right. This is because of the limitation in the dimensionless constant. For example, here we have 2. We cannot write any dimensions of 2. Again, in the previous example, here it was 1 by 2. So because of these dimensionless constant, this is the limitation of the dimensional equation. So dimensionally correct equation need not to be actually a correct equation. But yes, if a dimensionally incorrect equation is the wrong equation.